Everybody wants to fix scaling for Bitcoin, and I do too. And the way that conceptualize, way that I conceptualized trade layer scaling back in 2019. No, it's okay. I'm gonna restart. You just came in on it. Are you gonna like go pee? Okay. Yeah, tomato. So the way that I conceptualized the scaling of trade layer in 2019 at 5 in the morning when I was down on money. I was breaking into my credit in order to fund payroll, and I was like, "Oh, it's so late in the game," and it's like it was so not late in the game. Like people have started businesses around that time that are doing extremely well right now. But I took over reprogramming everything about a year ago and took control of my destiny and started making things happen. Okay, those jobs, yeah. With mostly my own acumen and a little help from my Bulgarian developer friend and colleague. And I re-implemented this. So the idea is like with Lightning, when you co-sign a transaction on a two of two multisig, you get instant finality when that happens. Kind of like how on something like Tendermint or a lot of L2 multisig type rollups, when you have two-thirds of the signers and it's a two of three times n multi-sig setup, come to that threshold of signatures, you have finality on a block, right? And that's why a lot of scaling, things like BitVM or what you see on Ethereum, like rollups, are all about bridging over to these kinds of setups. Now, to be fair, they're a little better on Ethereum than just a bunch of multi-sig signers. But it's basically Byzantine fault consensus. And then Lightning is like, well, we have these two of two signers, and you can like pull your money out, or you can cooperate, you can save money, and you can get a lot done more cheaply. But you have this limitation because they got into this sort of religious idea of Bitcoin being the only legitimate form of money, that everything has to be this chain of Merkelized unspent transaction outputs getting kicked around. Um, so with with TradeLayer, we're using op return transactions, and that allows us to have account-based money like you have on Ethereum on top of UTXO-based money. Um, and what that, see you later, buddy. And what that gets you is some problems and some benefits. And one of the problems is that it's an 80 byte limit in the op return, and that's as advertised. And in reality, as your string gets bigger, the hexadecimal bytes that get put in there will encode more stop to predict how long your op return is going to be. So it's actually worse. The real limit is something like 76 or maybe 77 bytes. So with most of these transactions, it is not really a problem. So like for instance, I'll run TradeLayer right now. Home office. All right. So we get the listener fired up. We run through the TX index, and it's parsing transactions and it's applying logic to them. So to give you an idea of what that looks like with the streaming kid, um, I'm doing this all in one take because I like the authentic flavor. It's a real startup life. So we got these payloads, and they look like this. So there's plenty of space. I have a few bytes for the marker. That's 2 bytes. I've got 1 byte for the TX type, and I don't bother with commas to separate parameters of unknown length. So Omni did this thing where they would do byte shifting, and I think they were using like a pointer array. So even if the number, for example, was a variable length, they could find where it was, and I had trouble with that. So I just did this approach, and it sucks because you lose a byte for every parameter on top of its size. And then I'm doing base 36 encoding for numbers, and I'm doing it on a E8 scale, E negative 8. So you got like the 8 Satoshi decimal interval. So for most things, it's no problem at all. And wada bing bada boom, we got real time mode. Okay. So when it comes to the L2, you got the ability to sign trades really quick. You just publish it, right? That's not really L2. That's just using the finality of co-signing to book the trade and then settle it right away. But as we fill up the blocks, so for instance, you might have about a million Litecoin transactions then, or about 2.5 million Dogecoin transactions a day. And there are about um, 60 times 60 times 24 minutes. What is that? There's 86,400 seconds in a day. So if you've got a pretty live DAX where people are publishing trades once a second, let's say, or whatever that would be like 10 to 30 times a second. You're going to fill up the blocks, right? So if you want to go to where, for instance, Bybit is and get serious market structure and you want to be executing on low latency on co-located co-signing server setups. I mean, how many transactions are going a second over here? It's something like 8 or 10. Yeah, sometimes six, sometimes four. Not too many, but it's got a lot of liveness. And the average ticket size isn't that great, but this is pretty much the state of the art in terms of how much liquidity at low latencies is going around in the Bitcoin markets. So if we're going to match that, we're going to fill up these blocks, and people are going to want to start to do L2 trades to save money because we're going to get a fee market on Litecoin, like we've had on Bitcoin. And so you're going to want to be able to sign a transaction and not have to publish it. And so this is where settlement comes in. So when you actually do the trade, you have a well, that's a problem. Put the expiry block in there. You have an expiration block. Oh no, it's on chain. That's fine. Here it is, trade contract channel. So I'm doing all this ad hoc. And you have an expiry block so that the partially signed transaction, when you're doing this handshake process, is not a free option for your counterparty for a very long duration. So it might be a few blocks away, and those options, with about 5 or 7 minutes of life in them, are still worth a few basis points, which is expensive. And we have half a basis point protocol fees here. So the idea is that you're going to have counterparties that are more or less reliable. But once you sign this trade, if you hold it past expiration, it's not going to work, right? So if you want to do it on L2, then you can pull your money out. This is like force close channel with a withdrawal, and you have a string on that. And then you can do transfers to route money around different channels. You can set the pay flag so that instead of your commit address that a withdrawal would pull funds out to being the same, it can be somebody else's address, maybe one that is hasn't even originally committed funds. So this would be a way for someone using MetaMask and an atomic cross-chain swap governed by some smart contracts to send their money to some smart contract on Ethereum or Arbitrum, and then have that intermediated by a smart contract on Near, and then you get a transaction that has a pay equals true transfer to your wallet address. And now your first interaction with TradeLayer, you're already on the L2, right? So this is what I think the Lightning people call this like a submarine swap type idea. So that's very cool. And then you're going to keep signing, right? And your wallet is just going to be pinging, sign, 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 especially the first time where you have not expired the thing yet. And once you have the idea is once you have the settlement, then you don't need to worry about the expiration because the logic in this is going to take care of that. But I needed two transactions because if you just have one transaction, and then I was going to have all these parameters to basically spin it and mold synthetically like an update with a lot of information. And then I realized, well, if I'm really going to have this thing work, there needs to be a recursive aspect to it where the second transaction that gets neutralized is the previous settlement. So that way you can just keep kiting these settlements all day long, ping, ping, ping. And eventually, if your counterparty goes quiet, they don't want to participate anymore, you publish your settlement and you publish the original trade, and that trade will be abridged by the settlement. It will still be valid. And you can force close the channel that way. But the problem is that TXIDs are pretty long. So the thing is, they could be in base 58, like public addresses are. But they don't do it that way. I don't know. It's an aesthetic choice. But they also, if they were, I think they would be longer because they encode more information, right? So you've got 64 characters. So I basically got very little room to do anything if I'm going to put this in raw. So then I tried doing them in base 94, which is the largest base size that you can encode in that uses the ASCII character set that we've been using since like the 1980s. And that was getting me about 40 bytes. So if I put in two, I'm already using up all my space. Technically, I'm going over by a few bytes. So then I thought, okay, I need to try some different bases. And I tried base 128, base 256, and I got some interesting results. But the problem is, um, you get this like Sigur Rós album cover looking weird characters, right? Which is fine unto itself. And this is from the UTF-8 set, which is a more modern set from the 2000s, which supports, Arabic and Japanese and Chinese characters and all kinds of and accents, obviously, and all kinds of stuff. And there's something like 64,000 characters in the set. And, you definitely get some savings compared to base 94 on a TXID. So this is taking us from about 39 bytes to a few bytes less, about 36, 37, depends on some of the details. And then it's even better with base 256. But then what's this? What is that? And that is a failure of the standard encoder to produce a character that is representable in this rather vanilla Windows PowerShell text environment. In other words, it creates a gap that's not deterministic to decode, and that is not acceptable. It needs to be something more robust than that. So I thought, well, maybe I have to give up and I have to just have one TXID and come up with a clever flag heavy, parameter heavy design and see what we can do with that. But then I went back and I thought, well, what if I make a custom base 256 encoder and I fill those gaps like here with other characters from this rather large UTF-8 character set so that it is deterministic and I can use it. So I did a draft with ChatGPT and I ran the system on a handful of blocks and we got a lot of gaps with the 128 and then we got some technical issues with making that fit, so I can't just take the gaps out. It has to be 256 to run that algorithm. And okay, so I got a cipher, a custom 256 cipher to work with a somewhat about half the fail rate of the 128. So that was promising. And then with a little bug due to assigning a constant, I wanted to count the number of transactions. I was able to get something that had a 100% success rate. And then I tested it on about 50,000 blocks, and I got the 100% success rate with over almost 120,000 transactions. So it works. And then I'm like, great. So now I can cram these two 32 byte dealies into the payload, and that's 64 bytes. TL markers 2, transaction type is 1, the comma between the parameters is 1, and a comma after this is 1. So that's 5 bytes. So that's 69 bytes. And since I can't really go to 80, I can only really go to like 76. That only leaves me with about 7 bytes. So I realized, okay, I have to get rid of all of this stuff. And I have to have the logic after this thing gets parsed, look up this transaction ID, decode it, check the opportune payload, check what actually happened in the trade, and infer whether or not it's a contract trade, infer the size of the trade, infer what's the collateral, or if it's a token trade, what's the other token that you're sort of angling for by bidding with the first token, um, and then figure out how much to give somebody. And then I thought, well, okay, so the only parameter that I'm going to actually use, other than these TX IDs, is going to be the quantity settled. But the problem there is you're dealing in decimals. You got 8 decimal places for standard token or Bitcoin, etc. Size, right? It's even crazier on Ethereum, but Ethereum doesn't have these self-inflicted handicaps, so they don't, they just use more space. And basically, that's not a good strategy. So then I thought, okay, what if I just put in the price? That way you don't have to rely on-chain Oracle. Maybe the Oracle isn't that reliable. You're doing this at a high frequency, more than one block. You're doing it every 5 seconds or something. And likewise, if it's a token thing, maybe there isn't that much volume in the token pair. So why rely on that? You're going to get stale data. No, you should be able to propose that to your counterparty and agree to that in the settlement to keep the channel alive. And so we're going to have the base 256 of these two guys. We're going to have the mark price agreed, and then whether or not it's a close. That's going to modulate how the first transaction is handled. And that way, so for something like the price of Bitcoin in the future, you're going to have a tick size that's going to eliminate decimals, right? As we're already usually going on whole dollar amounts. So here's a price in the 8 figures with no decimal, and it decodes to this guy, which is just 5. By the way, this is a cool project. You should download it. You get points for running an AI node. I recommended somebody invest in this back when it was just a blockchain. So 5 bytes. So then you can cram in the comma and the Boolean to modulate how it's used. And 69 bytes goes to 76 bytes. Wham bam, thank you, ma'am. And that's how I solved scaling for Bitcoin DeFi.